Let's talk about symmetry. Our objectives here is to determine whether a graph is symmetric with respect to the x-axis and the y-axis and the origin. We're going to determine whether a function is even, odd, or neither, even or odd. So let's consider the points 4, 2, and 4, -2 that appear on the graph of x equals y squared. We're going to see it in the next slide. These points like these have the same x value, but opposite y values are reflections of each other across the x-axis. If for any point x and y on the graph, the point x comma -y is also on the graph, then the graph is said to be symmetric with respect to x. That makes sense. So if we was to flip this and said y is equal to x squared, well, then this would be a reflection of the y. However, we're working with x equals y squared. So here we go. When we plot the order pairs, what do we have here? We have 4, 2 and 4, -2. What some of you are probably confused as to how they get the rest of the graph. So what we could do is take this x equals y squared, create an x and y table. Well, they said if we let y be 2, well, we square it, we get 4 for x, right? And I said, what about -2 for y? Well, when we do that, then I got -2 squared. Well, that's just 4 for y. Let's pick another point. What if I said y is 0? Well, 0 squared is just 0, so I get the order pair 0. All right. The reason I kept choosing to plug in for y is because I got it set equal to x, and y has the square on it. All right, so now I'm going to take these order pairs. Well, they've already plotted 4, 2 and 4, -2. And then we have the order pair of 0, 0. Excuse me. So that's this point here. How do we know we got a parabola? Because of the squaring here. And it opens to the right, and this is in respect to x. Okay. Now the symmetry of it is going to be right here where x equals 0. And split it in half. It's symmetric. It's symmetric at that point. So now what if they gave us points 3, 4, and -3, 4, and they gave us this equation here. So again, if you wanted to, you can create a XY chart. They already did some of the work for us. They said when x is 3, well, we plug in 3, square it, subtract 5, we get 9 - 5, which is 4. So they gave us that one. They said, well, when x equaled -3 and square it, well, what do we get? -3 squared is 9 - 4, which is 5. So now we get, whoops, that should have been a 5. I changed that. So now we get -3, 4. What if I said, okay, x is going to equal 0? 0 squared -5, well, that's just -5. So now I get -5 for y. So now I can come and plot this on the graph. And I got my -5 right here. That order pair is 0 and -5. And then they already plotted the order pairs solved. All right, so we got this parabola that opens upward. It actually gives us a minimum value right here, right? This minimum value happens when y is -5. It occurs at that point, and it occurs when x equals 0. If we wanted to know what's symmetric, we'd say the symmetric line is when x equals 0. And it's a reflection about the y-axis. Okay, so now we got something just a little bit more in depth, right? So we have x squared is equal to y squared plus 2. So looking at this, they said, well, what if x is -3? Let's square it. Let's solve for what is y squared. So now I get to subtract the 2 from both sides. So now I got y squared is equal to -3 squared is 9 minus that 2, which is 7. So now to solve for y, we have to take the square root of both sides. Now I get y equals square root of 7. So that's how they got that ordered pair. And then they plugged in for x3. And they came out with the negative square root of 7. All right. Now let's talk about what if we said x is 0, or we could choose y is 0. They're both got the raised to the square, so there's going to be a little bit of work to do no matter which direction I go with this. So if I chose to let x equal 0, well, now I got 0 squared, which is 0, y squared plus 2, subtract the 2 from both sides. And what happens here? We get y squared is equal to -2, and you take the square root of both sides. This value doesn't exist. We get an imaginary square root of 2. So let's look at this right quick. So when we get that point, this is a helpful hint to let you know that I'm going to have two functions going on. And this is actually a hyperbola. And how do I know it's a hyperbola? If you know the formulas, and you may want to go back to the notes with the list of formulas, hyperbola and ellipse will have both values with a square on it. However they are written, both variables will have a square on it. And this graph rotates about 180 degrees of the origin. So we know right here it's not real. That told us that that function wasn't happening at 0. We get an imaginary. So what we'll have to do is plot what we have and then find the other values by creating the x and y table. The x-axis, if replacing the y with negative produces equivalent equation, then the graph is symmetric with respect to x. Y-axis. If replacing x with negative x produces an equivalent equation, then the graph is symmetric with respect to the y-axis. The origin, if replacing x with negative x and y with negative y produces equivalent equation, then the graph is symmetric with respect. So basically, when we are working with parabolas, if I get, let's say, -2, 4 here, and I get +2, 4 here, they're respect to each other, right? So then this one here is a respect to the x or the y-axis. Does that make sense? So and so on. So like what ago we had the -3 square root of 7 and leaving -3 negative square root of 7. Might have been positive. I believe it was positive. Okay. So our example says we have y is equal to x squared plus 2, and we want to see where the symmetry with respect to x is. So when we do that, we're going to replace the y value here with the negative y. So now I got negative y is equal to the x squared plus 2. We're going to divide by the -1 because we need y to be positive, and this negative value is going to change everything over here. So now we have our resulting equation that's not equivalent to the original equation. So the graph here, so when we do this and it's not equivalent to this, then it's not symmetric. But if it comes back to be equivalent, then we have a symmetric equation. So what if I said, well, instead of changing the y, let's change the x, positive x to the negative x. and will it give me back what was equivalent to it? So if I take that negative x and square it, because that's what the formula, the function here is, we know that negative squared is positive, and we still come back to this. So yes, it is respect to y-axis. Okay, and that's showing you how to graph it. If the graph of a function f is symmetric with respect to the y-axis, we say that it is an even function. That is for each x in the domain of f. Okay, so we get this. If the graph of a function of f is symmetric with respect to the origin, we say that it is an odd function. That is for each x of the domain. We have this. Now, it says, given that this function f of x, we're going to find when f of negative x. So this means that if f of x is equal to f of negative x, then we have an even function. If I say negative f of x, simplify and compare it with f of negative x from step 1, then we get f of negative x is equal to negative fx, then that's odd. Except for the function of when f of x equals 0, a function cannot be both even or odd. And y'all, just a quick reminder, 0 is not even and it's not odd, right? Everything on the left side is negative and everything on the right side is positive, but 0 stands alone. It's neither nor odd. This is why this is true. Now, if f of x does not equal 0, we see in step 1, then we get f of x is equal to f of negative x, then f of even. We need not to conclude. So let's do this. Let's determine if it's even, odd, or neither. So we are giving this f of x is equal to 5x raised to the 7th minus 6x cubed minus 2x. And we're going to determine if even, odd, or neither. So in order to do that, I want to plug in negative x everywhere as I see x and see what happens. So when we do that, 7 here, that power of 7 is odd. So if it's odd, then that means we're still going to have a negative on the, still going to come out negative, because I can multiply something an odd amount of times and get a negative answer. This cube here is odd, so we're still going to have that negative. However, the power of 1 here, still going to have that negative. So we need to distribute that negative out. When we do that, what do we get? We get negative 5x to the 7 plus, because negative times negative is positive, 6x cubed plus negative times negative is positive again. So it's not even, if you notice, because it did not give me back what I started with. So it's definitely not even. All right. So if I was to plug the negative on the outside of the function, so you notice it's on the outside, and we distribute that negative sign to everything, does it do the same? Well, negative times positive is negative. Negative times negative is positive. So this is true. It says that negative of x does equal the negative of f of x, so that it is odd. So what you had to do is go back to that in step 1, and we got this negative f of x, and what it came out with, did it equal this? And if so, then it is odd. If not, and it failed both attempts, then we're going to say it's neither. And then you can graph it here. Thank you.